we are going to derive law of sines that is going to give us a relationship between the lengths of the sides of this triangle and the sines of the vertical angles. Okay. And now what we have to assume here is that these vertical angles A, B, and C, each one of them is a non-zero angle. Okay, so to do that, let's drop a perpendicular from, say, this vertex to the opposite side, and let's assume that the length of this perpendicular line is h. Okay, now this angle here is a, excuse me, this angle here is a right angle, right? Okay, so what we see now is we have two right angle triangles here. First, let's look at this right angle triangle. H is the side opposite to the angle A, and B is the hypotenuse. So what we get from that is that H is B sine A, right? And at the same time, if we look at the other right angle triangle, that is the right angle triangle here, then the opposite side to H is B and the hypotenuse is A. So according to this triangle, H is going to be A sine B. Okay, so what that gives us is this, that we have H equals B sine A and also A sine B. Okay, now if we go ahead and divide this equation by, say, AB, then what will happen is, or what we will get is, that we shall get, so division of both sides by AB is going to give us, or let me just show you the calculation here. Okay, say algebraically. All right, so we are going to divide both these quantities by what? AB. Okay, so AB here, then we have AB here. Now what will happen on this side? That we have these B's cancel out, right? And then here the A's cancel out. Okay, so what we have is that sine A over A is sine B over B, and you can just go ahead and extend it to sine B over B equals sine C over C. You can go ahead and drop a perpendicular from this direction and deduce that. Okay, so the whole thing comes out to be what? That the ratio of the sines of vertical angles to the lengths of their opposite sides are the same, or to read it out, sine of the angle A over the side little a equals sine of the angle B over the side little b equals sine of the angle C over little. So let's go ahead and apply this law of sines in a scenario. That is, say we have a tilted tree close to this house, and we can measure this angle as 84 degrees, and this angle of elevation is, say, 53 degrees. And this length from this point from where the angle of elevation was measured is 25.5 feet, and we have to use this to obtain the length of the tree. Okay, so what we can do is, let's see this here, we have this angle, how much? 53 degrees, right? Okay, and let me darken this for a second. Okay, and this angle here is 84 degrees, right? So who this angle will be? This angle will be, so this angle will be 180 degrees minus the sum of these two. So let's calculate that. 180 minus 53 minus 84. So that is going to be 43 degrees, right? Okay. So now what we can do is, see, this distance is given to be how much? 25.5 feet. And the angle opposite to this angle is 43 degrees. And we have to find h, and the angle opposite to h is 53 degrees, right? So what do we have? We have simply this, that h divided by sine of 53 degrees. Sorry about this writing problem. Okay, that equals how much? 25.5 here. Okay, so 25.5 divided by sine of how much? 43 degrees, right? So how do we obtain our h then? You can see h will be what? We just multiply the entire equation by sine of 53. So h will be equal to, let's bring this whole thing. So what we are going to do is we are simply going to multiply this with, oh, just a second. That's what I intended. I want to just copy this here. Okay, and we are multiplying by sine of 53. So here we have sine of 53 coming over here. And now you can do this. Bring your calculator, set that in the degree mode. Okay, so yeah, it's already in the degree mode. Okay, so we will go 25.5 times sine of 53 divided by sine of 43. So the length of the tree turns out to be how much? 29.86 feet approximately, right? So h is 20, I forgot so quickly, but anyways, 29.86 feet. Okay, so that's one of the ways you can use the law of sines. All right.